Good evening, everyone. Today is 15th December 2021. The time is 6 p.m. So let's begin our class. I'll present my screen first. So today is the class one, as there are no students. So let's learn something interesting. Today, the first topic which we will learn is regarding electricity. So, have you ever wondered how the regulator on the electric fan works? The fan at your home, which is on the ceiling, how the regulator changes its speed, numbering from 1 to 5. We will discuss it today. How does the regulator of electric fan work? So let us look at the circuit diagram. This is the AC power supply, which is coming from the power station, and it is inputted into your house in the meter box. This circular circuit inside this dotted rectangular box, it is the circuit for the regulator, the conventional regulator made up of resistances. These ones. And this is the ceiling fan, which might be at your home also, or the different fans, which are the standing fans. In that also there is a regulator. So before moving deeply into this topic, quickly let's go through the series combination of resistances, how the current and voltage division occurs in the series circuit. Suppose this is our circuit. In which we have three resistances whose electric resistances R1, R2 and R3, and this is a DC battery of potential difference V. So by convention the current will flow from positive to the negative side. Let that current be I. So in series, by formula we have, or by convention we have, the total resistance is equal to the sum of all the series resistances. Here we are talking about electrical resistance. So this will be the total resistance, and using Ohm's law, that is V equals to IR. The potential difference across a resistance is just the product of current through that resistance and electrical resistance of that resistor. So now we will calculate the potential difference across each of these three resistances. So from here we can get I as V total by R total, like treating this whole circuit as there is one V total and one R total. So V total will be nothing else but V only, because there is only one battery in this circuit. and R total by this formula from here, we can see R total is R1 plus R2 plus R3. So I will be nothing but V bar R1 plus R2 plus R3. Okay. So now let us calculate the potential difference or potential drop across individual resistances. That is, say the potential drop across R1 is V1, R2 is V2, and R3 is V3. So the potential drop across R1 will be nothing else but current passing through R1, which is same as I, because there is only a single wire, or you can say the linear track throughout the whole circuit. So I will pass through all of these. There is no divergence for current to split. So VR1 will be using Ohm's law, I into R1. And I we will use from here this equation. So it will become V times R1 upon R1 plus R2 plus R3. Similarly, for resistance 2 and resistance 3, it will be IR2, it is VR2 upon R1 plus R2 plus R3. And VR3 will be IR3 is equal to VR3 times R1 plus R2 plus R3. Okay. And suppose this quickly, yeah. Let's make a new diagram again. This is R1, R2, R3. I'll make it more spacious. R3. Same potential battery or the DC battery is connected, that is equal to V. This is a series circuit again. Same circuit from before. Now suppose I want to calculate potential difference across the two combinations of resistance, which is R1 and R2. That is VR1, R2. This is V underscore VR1, R2. So it will be nothing else but the summation of individual potential difference across R1, that is VR1, and across R2, that is VR2. So we have VR1, R2 equals to VR1 plus VR2, because it is a series circuit, series connection. And in practical applications, if you want to measure this potential difference, so we use a device known as multimeter. Or before multimeter, I would say we use voltmeter. voltmeter for measuring potential difference. This is the analog version. Means there is no electrical digital ICs. There inside this voltmeter there are coils and other material pieces, and there is another one called multimeter. This is also used for measuring potential difference and many other applications. For our interest, we will measure potential difference only. In this, it has digital, you can say digital electronic circuits, like integrated circuits like ICs. And these resistors in the lab also, these are usually the carbon resistors. And the connecting wires, they are made out of copper, Cu. Its atomic number, you must know, is 29. And battery, you can say it's a 5-volt DC battery or 5-volt power supply. So that's how a circuit is made. Now, getting back to the main question, let's draw some observations before from this. Our main aim is to see how the regulator works, but before that, we are studying this series circuit analysis. So, what are the observations? Number one is that the resistance is added when the resistors are in series, like this equation here, this one. R total equals to R1 plus R2 plus R3. What it means is resistance, let me be more precise by saying electrical resistance is given by addition of, you can say, individual or each resistance in series combination. Okay. What is the second observation? Second observation we saw is that the potential difference across a particular resistance is directly proportional to its own resistance. That is, VR1 is proportional to R1 and VR2 is proportional to R2. So what will happen is potential difference or potential drop across a resistance R is proportional to the resistance itself, its own resistance, which is basically the Ohm's law. So what will happen is, greater the value of R, greater will be the potential difference across it. Let me give you a quick example. Suppose we have two resistances, one is 5 ohm and another one is 10 ohm resistance, and the potential applied across it is 15 volts. what will be the total current in the circuit? I will be 15 upon R total, which will be 5 plus 10, that is 15 ohm. So current is 1 ampere. Now the potential dropped across the 5 ohm resistance, let's call it V1. It will be, here it is V1, and the potential across 10 ohm resistance, let's call it V2. Okay, so V1 will be I into R1. I we just calculated, it is 1 ampere, and this R1 is 5 ohm. So we have 1 into 5, that is 5 volt. 5 volt. And drop across the 10 ohm resistance will be I into R2. It is again 1 into 1 is the same current because it is a series combination, and 10 is the resistance here. So it gives us 10 volt. So we see that we inputted R2 as greater than R1 because 10 is greater than 5. So R2 is greater than R1. So what we see is that the potential difference V2 is greater than V1. This tells us that V2 will be greater than V1 because why? Because V is proportional to R. Okay. Now we can get back to our question. So now here is this circuit of the electric fan, which is being powered by this AC supply, and there is a regulator. Okay. So these numbers are the ones which are written on the regulator knob. 1, 2, 3, usually up to 5, and there is one 0 or either 0 or it is off. So how does these numbers depict the speed of the fan which is connected to the AC power supply? For now, we will just consider electrical resistance and we'll ignore the capacitance and inductance for the sake of just understanding how the regulator works. Only electrical resistance will be considered. So, as you can see here, just quickly copy it. Okay. So, in this one, when this knob is turned to 1, or before that, if this knob is say turned to 0, but if this knob is turned to 0 and there is no connection here, so what will happen? The circuit is broken and the fan will not start, it will not rotate. It's simple as that. But when the knob is at this number 1 here, the circuit is connected, and now in this circuit we have AC power supply, then there is these resistances connected. Let's say these all resistances are equal. So for when the knob is at the 1, what will happen is that all the 4 resistances are inside the circuit. Okay. So now this say like this, and here is our fan. Okay. So at when the knob is at 1, the circuit is equivalent to like this. If there are 4 resistances, current is passing through here. Let's take only the single direction, and then it goes through this whole circuit. It comes out, then it is fed into the fan. So before going into the fan, the current sees these 4 resistances and then the resistance of the fan itself. So the total current yes, the total current seen by the fan is, suppose the V power supply is, the voltage drop is V, the RMS you can say. So the IRMS will be, or you can simply for the time being just treat it as a DC supply. So it will be easy to understand. You can think of it as a small motor fan, which will, the principle will be same only. So the current here will be V upon these 4 resistances, 1, 2, 3, 4, and the fan resistance. So we see that all the resistances when incorporated, the current will be very small because this denominator is large. And this, when current passes through this circuit, the voltage drop across the fan will be this I into R fan, which is nothing else but V upon 4R plus R fan multiplied by R fan. So you see that the denominator is big because the current is small here. This quantity itself is the current, which is very small. So what it leads to is that voltage drop across fan is also small. So the power dissipation, we can say, is will be small across the fan. If you don't know about power, then there's no issue. There's no need to worry about. You can just consider it as the input voltage to fan is small. So the output will also be small. If we feed something small to a device, it will also create some small output. So here we are feeding small voltage and we get less speed. Okay. Now let's see the next step. When the knob is say turned to number 2, and from here now the knob is turned to number 2. So what you can see is now this resistance is left outside the circuit. The current will come from here, go here, and then we will just follow the material path. So it will go from here to the point 2. And it will not go to the left side because there is no connection ahead. There is a broken connection. So the current will go to this side, then here, then it will be fed into the fan. This time what will be the difference is when knob is at 1, the regulator knob is at 1. There are only 3 resistances this time. So resistance will be 3R and resistance of fan with the same power supply, DC for the time being. So current this time will be voltage upon 3R plus R fan, and voltage drop across fan will be I into R fan, that is V upon 3R plus R fan into R fan. Okay, so this is the voltage drop at V fan when knob is at 1, so let's call it V1. And this one when the knob is at 0, we use another color, this one, let's call it as V0. This one as V1. Okay, so this time what happened is the resistances inside the circuit are only 3 and 1 is outside, so it will not create any electrical resistance to the current flowing through it. So this time the denominator is smaller than before, because earlier it was 4 times R plus R fan. So the I was small. This time the I will be slightly more as compared to the earlier case. Let's call it I1 this time, and that one was I0. So if I is large, the potential drop across the fan will also be large, because it is proportional to I also. So now if you feed something slightly larger to the device, it will also give or create larger output. So here you provided larger voltage and it gives you more speed, or you can say greater speed. So it's coming nicely now. Let's look at what happens when the knob is at 3. Okay. When the knob goes to 3, the current will again flow from here, and it will go to this side again. It will not go to this side as there is no electrical connection ahead and there is a break in the circuit. It will go to this side and follow through the fan and come to this side. This time there are only 2 resistances, this one and this one, inside the circuit. So I will be V by 2R plus R fan. Excuse me. So the potential drop across fan will be V by 2R plus R fan, that is the current, times the resistance of the fan itself, that is the Ohm's law. So now we see that I3, I2 and I1, there is no 0, sorry. Yep. And 1 and I1. At 0 there is no connection, so no current and voltage across fan. So this time the I3 is even greater than I2, because the denominator here it is 2R plus R fan, before it was 3R plus R fan. So this is, let's say, V3, and the last case, or the second last case, it will be same only. Like when the knob will be at this 4th position here, there will be only one resistance left, circuit which is belonging to the regulator. So for knob going to 4, current will be V by R plus R fan, and V fan will be V R fan times R fan. So now you can see the denominator is even smaller. So this whole quantity will be larger as compared to before, and the V4 will be greater than V3, V2, and consequently V1. And similarly for knob being at 5, what will happen is when the knob is at 5, there is no resistance from the regulator. All these resistances, they will be out of circuit. All the resistances will now be out of the circuit, and only this one resistance will be left inside the circuit. Okay, this is what happened for 4, and when the knob is now at 5, this resistance will also be out of the circuit. The circuit will comprise only power supply, so there directly comes back and directly fed into the fan. So for knob at 5, the current will be V upon R fan, and potential drop across fan will be V by R fan times R fan, that is Ohm's law, giving out V5. So how the knob was working is, when the knob was at the smaller numbers, that are the observations. When the knob is at smaller number, these resistors, or you can say the resistance inside the circuit, are greater. Resistance is large for smaller number on the regulator knob. So large resistance means current is small. Small current means potential drop across fan. Or you can say input to the fan. This is also small. Now when input is small, the output from fan, or in other words, speed, the rotational speed, the speed with which the fan is rotating, is also small. So finally we get is that when knob number is small, this all leads to output from fan to be small. That is small regulator knob number implies less speed of fan. This is also what we see. At smaller numbers, say the like 0, 1, the speed is less, and at 5, you can say the highest number in most cases, the speed is large. This is the first and like the chief observation which tells how the regulator knob controls or regulates the speed of the fan. So this was all to regulation of fan speed. If there are any doubts, you find like some topic or something difficult in this discussion, you can post it at the Aksharamaala platform in the doubt and clearance section, where I can answer it to you like whenever I get time, as soon as possible. And I request you again to join the classes regularly, because it will be beneficial to you only. Okay, so we have some time left. Let me see. It's recording, right? Yeah. So next topic which we will cover today is from the field reflection of light. Next topic is reflection of light. In this, we will look at an interesting question. The question will be, why different objects have different colors? Now, what does this question mean? Why different objects have different color? Suppose you are using your smartphone right now. You see some of your phone will be black, some of your phone will be white, and maybe some other color also. You are wearing some shirt, it might be of red color, blue color. Your pants will be black color or something else. Your house will be of white color, yellow color, orange, green, blue, any color. Like you have favorite colors also. It's like your favorite color is this and that. So why different objects possess those colors? What is the reason behind it? Why all the objects in this universe are not of same color? Okay, so like what is actually a color which is possessed by the object? So the answer to this question is lies in the reflection of light. We know that. Let me grab this image quickly. This image right here. 1 second. Okay. When we know that according to the laws of reflection, when a light is incident on some surface which can reflect the light at some angle I, the angle of incidence, it will be reflected back at the same angle. Or say, suppose for now the angle of reflection is R, that is at which angle it is being reflected with respect to this perpendicular line, which is also called as normal. So the law of reflection says that angle I is equal to angle R. This is the first law, and second law says that the incident ray, this one, the reflected ray, this one, the incident ray, the incident ray, the reflected ray, and this normal, they all lie in this same plane, this one. It cannot happen that light is incoming in this plane, say, and like it has to be defined by two lines. The plane has to be defined by two lines. So suppose the first line is this and normal you say is this. So this will be the plane of plane of incidence. Or you can say just an arbitrary plane. So the reflected light, it cannot just bounce off in any direction like this, or not in any random direction. This reflected light also has to lie in this plane only, this one, in which the incident and normal lies, and it has to be such that the angle it makes with the normal will be same as angle of incidence, which is the first law itself. The second law is that incidence, or you can say incident light reflected light and normal they all lie in the same plane. Now let's look why the objects have colors. Let's see this image first. We all know that apple is of red color. Okay, right? This is the apple and this is of red color. The first question is how we see the apple. So it's simple. The light from the sun or some other source like tube light or torch incidents on the apple. Let's take some of the colors. Say the white light incidents on the apple from sun or some other source, and it reflects the light back. And when this light when reaches our eyes, image is formed. This is how we see apple or any other object. All the objects, they reflect light which we can see. Okay. If an object does not reflect the light, we can't see it, or it will appear as black. We will see why it will appear black. So this is the first principle, how we see objects. Now let's see why the different objects have different colors. Here are these three objects, 1, 2, and 3. They have color red, white, and black. So when white light is incident on this object, Okay, so these three different materials have different properties. One of them different one of these differences in the properties is that they all absorb the light differently. In the first case, what is happening is this absorbs all the six colors out of the total seven colors in the white light. We know that white light is comprised of seven colors: violet, indigo, blue, green, yellow, orange, red. This first material, it reflects or it absorbs all the material violet, all the colors of light, sorry, violet, indigo, blue, green, yellow, and orange, and only reflects the red color back. So when this color is reflected, our eye perceives this reflected light and forms an image of this object as red object. So basically all the red objects will absorb other color of white light and only will reflect the red light. That is why apple is also red in color. It absorbs all other colors from the white light and reflects only the red color. Similarly for the second object, it instead of absorbing anything, it just reflects back all the colors. All seven colors are reflected. So initially the incident light was white because of there are seven colors. Reflected again there are seven colors though. So the reflected light is also white. So if I perceive this color again, so this reflected light, what it will see is a white object because the incoming light is white. For the third material, when incident white light is dropped on this material, when white light is incident on this material, which is of such properties that it will absorb all the colors. It absorbs all the colors. Colors are basically distinguished by frequency and wavelength. It says frequency, wavelength may or may not change depending upon the medium. So when it absorbs all the colors, there is nothing reflected back. If there is nothing reflected, there will be no light incoming in our eye. If there is no light inside, so it will be all dark. Suppose you go into a room and all the windows are closed, curtains are put such that there is no outside light coming. The door is closed and you do not switch on the light. So you can't see anything because there is no light source, no reflection from the objects, and no input to the eye, the reflected light. So there will be only dark. You can't observe anything. But suppose in the surrounding of this black object, there are other objects, a red object, some other color, a blue object. So instead of getting completely dark, there will be other objects like you can see. It's not a closed room, it's just an object. Suppose like your smartphone, which one you are holding right now, probably while watching the video, or your laptop or computer, it will be black and surrounding will have their usual colors like say red and white. So the object will appear black only if all the incident radiation is absorbed by the object and no light is reflected back. So let's quickly note down the observations. Object possesses one sec. Object possesses the color which it reflects back. So basically, it's not the material which possesses the color, but the object possesses the color which it reflects back. So it is basically the light which is being reflected from that surface. Suppose you paint a wall with red color or some blue color. So we say that the paint is of blue color. It's not actually the paint which is carrying the color. It is the structure of that material with which the paint is made or some additional substance is added to that lacquer, the paint, the white paint, such that it absorbs all the other light, all the other colors in the white light, and it reflects back only single color. So the blue paint material will reflect all the violet, indigo, green, yellow, orange, red, and will reflect blue. The red paint will absorb all the violet, indigo, blue, green, yellow, orange, and only reflect red. So we say that the object possesses, that is, the object has the color which it reflects back. Okay, so here we are implementing white light and it reflects only one color back. Excuse me. So this is our answer also. Why the objects possess different colors, why different objects possess different colors. So let's quickly summarize what we did today. First was how regulator works, and second was how or why objects have color. The answer to first was that small number incorporates, that is, it inputs lesser resistances, lesser number of resistance, you can say, into the circuit, which leads to small number inputs more small number more number of resistances, which implies lower potential difference or potential drop across device, say our fan. That is basically small input to the fan, which will imply small output from the fan. That is the speed. Similarly, for large number, large speed. And why objects have colors, different colors? It is because of the properties of the object, or the matter out of which it is made, the properties of the matter out of which the object is made. The color the color of the object is decided by the color of the light it reflects. Like a red object reflects red object, or let's say object reflecting red light will have red color. Object reflecting or say absorbing all the colors will have black color because it does not reflect anything. And there can be another property also, like if an object that just allows to pass all the colors through it, instead of absorbing or reflecting, it just transmits all the colors. In that case, I'll leave it for you to decide what will be the color of the object when it transmits all the colors. Maybe put it in the comment section so I'll reply if it is correct or not. And for the students, you can answer in the next class. So that's all for today. And thank you for watching the video.